Hi, welcome to another episode of Science Made Simple. I'm Miss Shanise, and I'm a secondary science specialist here at the Pique Lab. In this video, I will be analysing a past year exam question. I've also prepared this question for you to download for free by clicking the link in the description box below. So let's get started. Question 14. The diagram below shows how to obtain pure water from seawater. But before we dive into the question, let's do a little recap. Is seawater an element, a compound, or a mixture? Since seawater is made from salt, as well as water, seawater contains more than one substance and is therefore a mixture. Specifically, we can say that seawater is a solid liquid mixture. So how can we obtain pure water from seawater? Since mixtures are only physically combined, we say that we can use physical separation techniques to separate its compound. But what physical separation technique are we looking at over here? This is a distillation setup. The question is asking, where do water molecules lose energy? What form of energy do you think that this question is referring to? If we remember what we have learned in primary school, you might remember the 7 key heat processes, such as evaporation, condensation, freezing, and boiling. In this case, water gaining or losing heat might be referring to thermal energy. Now let's take a look at what are some of the key processes that are taking place here. If we look at the Bunsen flame, we know that it is to provide heat to the seawater in the distillation flask in this area over here. Eventually, what is going to happen to the seawater? The seawater will boil. So boiling is the heat process that we are looking at within this green area. Now recall, what is the change in physical state that occurs during boiling? Boiling is a change in state from liquid to gas. For boiling, are we looking at a heat gain or a heat loss? We are looking at a heat gain, which is a gain in thermal energy. But since the question is asking about losing energy, which refers to a loss in thermal energy, can point 2 be the answer? The answer is no. Now, let's move on to the next part of the setup that is known as the condenser. The purpose of the condenser, as the name suggests, is to condense water vapor that is going through it. Recall, what is the change in physical state that occurs during condensation? Condensation is a change in state from gas to liquid. Looking at the state changes of both condensation and of boiling, do you realize that boiling and condensation are opposite processes to each other? So if boiling undergoes a heat gain, condensation must undergo a heat loss. Or in other words, a loss of thermal energy. This ties in nicely with what we have learned in primary school, isn't it? We learned that warmer water vapor loses heat to a cooler surface and condenses to form water droplets. However, now that you're in secondary school, you have to explain using kinetic energy instead. Why? We have learned in kinetic particle theory that during the different heat processes, thermal energy is converted into kinetic energy, and that temperature is a measure of the average kinetic energy of particles. So when we are talking about losing as well as gaining heat here, we are actually talking about kinetic energy. So let's check if the water molecules at point 3 do lose kinetic energy. We have learned in the topic of particulate nature of matter that gases, they are able to move freely and randomly at high speeds in all directions, like so. So if they are able to move so quickly at high speeds, do you think that gas particles will have high or low kinetic energy? Gas particles will have high kinetic energy. Now what about for liquids? We say that for liquids, liquid particles are only able to slide over one another. In that case, we say that liquids will have lower kinetic energy. In condensation, when we go from the gaseous state to the liquid state, are we looking at a gain or loss in kinetic energy? We are looking at a loss in kinetic energy. And this checks out with what the question is asking for, which is where do water molecules lose energy? As such, our answer should be option 3. For option 1, we are simply pointing at the Bunsen flame. Now, do you think that there are any water molecules in the Bunsen flame? The answer is obviously not. Therefore, option 1 can be ruled out as a potential answer. What about option 4? We are looking at a beaker of pure water. Do you think that anything is happening to the pure water? The answer is yes. Imagine a cup that you have placed outdoor for a couple of hours. Eventually, do you think that the water level in the cup will rise or fall? The water level in the cup would fall, and that is due to the process of evaporation. In evaporation, what is the state change that we are looking at? We are looking at a state change from liquid to gas. Looking back at the diagram that we've drawn, from liquid to gas, are we looking at a gain or a loss in kinetic energy? We are looking at a gain in kinetic energy. And is that what the answer is looking for? The answer is looking for a loss. Therefore, option 4 doesn't answer the question and can be ruled out. As such, our answer is option 3. Thank you for watching, and I hope you have enjoyed this video. Found this video useful? Give us a thumbs up and check out more by clicking the links here. You can also subscribe to our channel for more interesting videos. Until next time, stay curious inside and limitless outside. Bye!